All right, jumping right back in here. I'm on 23. 23 is a bit messy. The problem is, again, we have a square root in the denominator and we need to fix that. There's more than one way to do these problems. I think there is an easier way to do it. And I'm going to try that way. So I think the easiest way is to simplify the denominator first and then try to get rid of any square roots on the denominator. Okay, so kind of ignore the top for now on the fraction bar. Just look at this and simplify square root of 27 x squared y. So 27 has three threes in it. So I'm going to put the double threes in front and a leftover 3 in back. Square root of 9 is 3. And square root of 3 does not simplify. Okay, as far as the x squared goes, what's the square root of x squared? That would just be normal x. Because x times x is x squared. And square root of y, does that simplify? No. So it's going to stay under the square root. Okay, so this is my new denominator. So I'm going to rewrite this problem. Okay, now my problem is I can't leave a square root in the denominator, so I'm going to use the same trick from the last problem. If I multiply a square root times itself, it's going to get rid of the square root. So I'm going to multiply the top and bottom by square root of 3y right there. So the top, all right, I'll put it over here. 3 times 7 is 21. And that's not going to simplify. That's good because 21 is just 7 times 3. There's no doubles in it. And then x and y. And then the bottom, square root of 3y times square root of 3y is just 3y. So we have 3x times 3y. And order of multiplication doesn't matter, so I can go ahead and multiply 3 times 3 is 9 times x times y. 9xy. Does this reduce? No, because this is a square root. This is a normal number, normal letters. So no, that's all we can do. So that's the answer to 23. Right there. All right. $25. Okay, we kind of mentioned this earlier on a problem. When you're adding and subtracting, you can only add and subtract the same radicals. So, like these square root of 6's can go together. This square root of 24 can't mix right now, but if we simplify it, this is kind of why we simplify it, we might find out it's actually a square root of 6 in disguise, and then it can mix. So this square root of 6, does it simplify? No, 6 is 3 times 2. There's no doubles in it. Square root of 24 does have a double in it because 4 times 6. So there's a double 2 inside of it. 2 times 2 is 4, left over. 3 times 2 is 6. Square root of 4 is 2. Square root of 6 doesn't simplify. So that middle term is actually a 2 square root of 6 in disguise. So, okay, I'm going to rewrite it. The first term, and the square root of 6 doesn't simplify either. The first term is square root of 6. There's no number in front, so how many do we got? 1. So I'm just going to write it as 1 square root of 6 minus 2 square root of 6 plus 5 square root of 6. So it's kind of like 1x minus 2x plus 5x. Okay, it doesn't really matter. That second value is just going to stay. So what's 1 minus 2 plus 5? 1 minus 2 is -1, plus 5 is 4. So this is 4 square root of 6's. 4 times square root of 6. That is it. Okay, that's 25, 27. Cubed roots, cubed root of 7. Okay, so we're going to try to simplify these before we add or subtract, and we need triples to be able to simplify it. 7 is a prime. It does not simplify. There's no triple in it. There's only 7 in it. Okay, 56 is 7 times 8. 8 is 4 times 2. Okay, so there is a triple 2 inside of 56. So 2 times 2 times 2 is 8, and the leftover is that 7. Cubed root of 8 is 2. Okay, that's the middle term. Back here, 189. I'm not sure yet, but 189 looks big enough. Probably has a triple in it. Okay, 1, 8, and 18 and 9. 9 goes into both of those. So I'm going to divide by 9. Looks like it'll be a 21. And looks like there's a triple 3 inside of 189. 1, 2, 3. So 3 times 3 times 3 is 27. And then there's a 7 left over again. I'm going to bring the minus down. Cubed root of 27 is 3. I mean, that's where it came from, the 3's. And then the cubed root of 7 doesn't simplify. Okay, and then up front here, we had a cubed root of 7 added. Okay, they're all cubed root of 7, so that they're all going to go together. So we basically, no number in front, so we have 1 of those plus 2 of those minus 3 of those. 1 plus 2 is 3, minus 3 is 0. So we have 0 square root of 7's. Now if you wrote the answer as 0 square root of 7, or cubed root of 7, sorry, technically that's correct, but 0 of anything is just 0. 0 times anything, 0 of anything is just 0. So just write 0 for that one. That usually annoys people when we do all the work and we get an answer like 0 or 1. Tough luck. 29 looks like a, what kind of problem is 29? 2 plus 3, 2 minus 3. Hopefully you figured out it is a FOIL problem. So we need to multiply the first 2, the outside 2, the inside 2, the last 2, and that would do it. But if you did that, you would get the correct answer. But this is not just a FOIL problem, it is conjugates, which meant, we talked about this last week, it meant that they're the same thing, but there's a plus and a minus in the middle. So what's going to happen is the outside and the inside pairs, when we FOIL it, would cancel out. I'm going to go ahead and do the whole FOIL, I guess, just to show you that they do cancel out. Okay, if I starting with FOIL first, square root of 2 times square root of 2 is square root of 4. That is normal 2. Outside, square root of 2 times square root of 3 is square root of 6. There's a minus, so it's negative square root of 6. Inside, square root of 3 times square root of 2 is positive square root of 6. Okay, they're going to cancel out. And then the last 2 are square square root of 3 times negative square root of 3 is negative square root of 9, which is negative 3. Okay. Outside inside pairs are opposite. They will cancel out. This is just for conjugates. And then the 2 and the minus 3 back there can go together. 2 minus 3, negative 1. Okay, the end. Okay, 31. Okay, a little bit like 21. It's got a square root on the bottom. We're not supposed to leave any radicals in the denominator. So how do I get rid of it? You can't just multiply this one by square root of 2, because you'd have to multiply the entire bottom by square root of 2, so it'd be like 3 square root of 2 plus 2. So we'd still have a square root in the denominator, wouldn't fix our problem. So what we have to do is use the conjugate, because the conjugate gets rid of those square roots. So I'm going to multiply the bottom by 3 minus square root of 2. And whatever I do to the bottom, I got to do to the top. The top is basically a distributive property. It's 6 times both of those. The bottom is a FOIL, because it's 2 terms times 2 terms. But we only have to do the first and the last because they're conjugates. Okay, let's start with the top. 6 times 3. 6 times negative square root of 2. Those do not mix. Normal 6 square root of 2. The 2 had a minus on it, so 1 negative makes a negative. Okay, that's the top. Do those two mix? No, they do not. Okay, cannot add and subtract. They're not the same kinds. The bottom is kind of like 29. I'm going to FOIL, but I'm going to skip and only do the first and the last. 3 times 3 is 9. And then the last is square root of 2 times negative square root of 2, which is negative square root of 4, negative 2. 9 minus 2, 7. Okay, does that simplify? Whoops. No, it does not. If this 7 were like a 6 or a 2, you could have divided both of those by 6 or 2. Or 3 would go into all of them. But it's kind of got to go into everything before you could reduce that. But this one does, 7 doesn't go into those. So that will be the final answer. Okay, can't just divide one thing by this number. You got to be able to divide both of them by that number if they're all in the same fraction. Anyway, either way, it doesn't simplify. So we're ready for 33. Okay. All right. We're solving the sides of a right triangle. We got to use something we learned about a week ago. Do you guys recall what that property is called? It starts with a P. It's probably the most famous theorem in math. It's called Pythagorean theorem. Theorem just means a rule that somebody proved. That always works. It goes with right triangles, and it sounds like a squared plus b squared equals c squared, where a and b are the legs, and c would be the hypotenuse. The legs are the shorter sides, and they're always around the right angle. C is the hypotenuse. It's always across from the right angle. If you think about it, a squared plus b squared equals c squared. The two smaller ones are adding up to the bigger one. Kind of makes sense, right? I called this one b just because. So, all right, so the legs, 12 squared plus b squared equals that squared. All right, 12 squared, 12 times 12. Just going to leave this b squared for now. That squared, it should work if you plug in your calculator with parentheses. You can do it without a calculator. 6 squared is 36. Square root of 6 squared is 6. And then 36 times 6 is 216. So you should get that in your calculator, hopefully. All right, solve for b. I need to get it by itself, so I'm going to subtract this added 144. What is that? Something weird. Let's see, that would be 56 plus 16, 72, I think. No, 56 plus, yes, that's right the first time. All right, 72. So if b squared is 72, well, what is b? B is what times itself equals 72. In other words, what's the square root of 72? That would be the answer. Another way to think about it is to get rid of the squared, you take the square root. But if you do that on one side, you have to do it on the other. Square root of 72. Okay, just like the previous problems, we have to simplify it. It's going to fall off your picture there. 72 is 9 times 8. Okay, so we're doing square roots, so I need the doubles. I know you guys can't see it, a double 3 and a double 2. So 3 times 3 is 9, 2 times 2 is 4, 9 times 4 is, 36. And I have 1, 2 left over. I know you can't see it, but so that's going to go in back. Okay, square root of 36 is 6. I think the directions, did they say we had to simplify this one? Because I just did. Oh, it says do two things. Simplify it, so we did that part, and write it as the decimal equivalent to the nearest hundredth. That's the second decimal place. So I'm going to plug this in my calculator. Actually, I'm going to pretend to plug in my calculator. Button. So this should round to 8.49. So actually they wanted both of those answers. The second part is kind of the easy part. If you just put that, I would have counted it as okay, but those are the same thing, basically. This is a little bit rounded off. That's why we leave it like this, just so it's not rounded, but that's it for 33. 34 is kind of the same thing, except for you're missing the hypotenuse, so you should set it up as 6 squared plus 10 squared equals c squared. So it'll work a little bit different than 33, but same idea. Okay, 35 and 37, and those problems, they have formulas that we learned last Monday. If you took notes, you should have those formulas. If not, I'm going to go ahead and write it down again. So on 35, it says find the distance. The distance formula is a little bit messier. Kind of got a lot going on. It's easy to switch around a plus or a minus or do it in the wrong order. So we subtract the x values, square it, subtract the y values, square it. Actually, these could be interposed, switched around. It wouldn't change anything. The book might have written it slightly. That's why I'm saying that. I don't know if the book wrote it a little bit differently, but mine is still going to work. All right, on 35, it says 1, 7, negative 3, 9. So the x values are going to go together. So I'm going to do 1 minus negative 3. Minus negative makes a plus, so that would be a 4. That's the first parentheses. And then the y's, 7 minus 9 is negative 2. Negative 2 squared. Alright. So the next thing is we did the parentheses. We're going to have to use the exponents now. 4 squared is 16. Negative 2 squared is positive 4. 16 plus 4, do everything in the square root first and then square it at the end, is 20. And 20 simplifies. I know there's a double in it because 20 is 4 times 5 and 4 has double 2's. So double 2's make 4. Square root of 4 is 2. Square root of 5 does not simplify. So that would be the distance. They did say simplify. They don't want a decimal on this one, so that would be the answer. Okay, so you're going to need that formula for 36 as well. 37 says find the midpoint. So we're talking about like an XY plane. So if we have a point here and a point here, the midpoint is going to be, somewhere in the middle. So this has an X and Y, this has an X and Y. These X and Y, the X and Y for the midpoint is going to be the average. So the formula looks like comma it's got an X coordinate, two different numbers, an X coordinate and a Y coordinate. The X coordinate is the average of the X coordinates and the Y coordinate is going to be the average of the Y coordinates. So looks like 37 is using the exact same numbers, which I erased, as 35. So my two X coordinates are 1 and negative 3. And my Y coordinates are 7 and 9. Order doesn't matter. The order of addition, 7 plus 9 is 9 plus 7, so it doesn't matter. 1 plus negative 3 is negative 2, divided by 2 is negative 1. And 7 plus 9 is 16, divided by 2 is 8. So on the graph at negative 1, 8, there's a point that would be directly in between the other 2 points they gave us on the graph. Alright, that's all you have to do for 37. I think those are a little easier than 35 and 36. Okay, 39, solving equations. Alright, so hopefully you remember this was the ladder assignment from last week. You want to get x by itself. How do I get rid of the square root? Well, what's the opposite of square rooting? Squaring. So if you do it to one side, you do it to the other. What happens on this side is those go away. And on this side, you get 16 times 16. The end. Pretty short and sweet. 41. Did I write that right? Yeah. Okay, so 41 is just getting a little messier. What we did was we got the square root by itself, then we got rid of the square root, and we got x by itself. So I don't want to square both sides right now because I'd have to do all of this times itself. It'd be a really ugly problem and it wouldn't help at all. So I want to get the square root by itself first. So how do I get rid of plus 8? Five minus 8. I'm glad this one wasn't odd because this is a weird one. I'll go ahead and tell you that the two evens on this page are not going to be like this one. This is the weird one. So, fortunately, it is an odd. Okay. Normally, the next thing we would do right here, since the whole left side is under the square root, we're ready to square both sides. So the left side would become x minus 2. The right side, negative 3 times negative 3 is 9. And now we got a really simple equation. We just need to get x by itself. Okay, well, that didn't seem that hard. What's wrong? Well, if I plug 11 back up here, 11 minus 2 is 9. Square root of 9 is 3. 3 plus 8 is not 5. So what happened was I got an answer that didn't work. That happens sometimes when you square both sides and one side you're squaring is a negative. That happens pretty much every time. So you're going to get an answer that doesn't actually work. So this one has no real solution. We're just going to say no solution. On 41. So good news is 40 and 42 have normal answers. So you don't actually have to check, but that happens sometimes on these square root problems. So you can always, when you're solving equations, check by taking your answer and putting it back in to make sure it works. If you do enough of these, you kind of realize that's going to happen every time you square. The right side is negative and you square it. It's going to get an answer that doesn't actually work. Okay, that's it. You guys can email me if you have any questions. Hopefully this makes sense for you, and good luck.